Good afternoon. Well, here it is the next day, and I just want to give you a little update on how things are going here. I took out the motor, which was mounted here like this in this bracket, which drove this here Acme thread. This was on the spindle head stick, this hairpin that I made, and when this thing was turning, it turned the head. But I want the head to go faster, so we're removing all this, and we're gonna, as I said, do a simple, crude system. I have some snapshots that I'll be showing you so you can see how this was put together. Temporarily, I stuck this up through here, held it in place, put the wires on, and clamped it here, and tried to run it. First of all, there's not enough torque here. This is a 150 RPM motor. It's way too fast for this. It was okay for turning the Acme thread. It gave the right gear down, so it had the torque. It does not have the torque now. So here is the setup. Now this is the original way I had it, except I had a mouth trigger and I was operating this by hand, and the mouth and the eyes and so forth before I modified this, and you got the familiar comical shake of his head, which I kind of liked. But if you look up here, when I built this, it's on 2 pieces of thin plywood, no real bearing, and got grease on it and so forth, so it's hard to turn. Looking at the back, this is 2 ears here, this is the back of the neck. I can turn, no problem, turning his head to his left. Not a problem this way. This is really about as far as I can turn his neck to the right, because it binds up in here, because this is not a very good system. And this is where the problem is going to come in because of the way I built this. But this don't look all that bad, even if the head only goes that far. That's not a problem. But you see, the way I made the material here, we're working against the material too. Because I redone, if you watch my videos, I got rid of the Adam's apple, and his neck was real skinny at the time. But there, at the bottom of this, if you look back on building Uncle Dorkel, the very early stages, you'll see that there was a head stick and a round piece of like fiberboard, actually, about a 1/4 inch thick, and it sat on more fiberboard, and there was lithium grease on it, and then those little clips that I showed you up underneath. So there's no real good bearing surface here. I didn't want to, well, basically, you know me, I try to build things on the cheap, and sometimes it doesn't work out. So in order for me to get a bearing and everything in here and making the head very easy to turn, I would have to literally tear him all apart, and I'm not going to do that. I've done enough already ripping him apart. So I took out the stick. This is where the stops where the micro switches hit. Temporarily took out the amplifier, but I will be putting that back in. This is the bearing, part of the bearing for the Acme thread, which will not be used. It'll be used maybe for something else, but not for the head. It's like marbles. It's sliding all over the place here. And they're impossible to rake up. They just go right through the rake. So as I slide my way through here, So, as I recall, the name of the place was American Science and something else. I can't remember. I tell you, my mind is like a sieve sometimes. And I got this motor, it was about 2 years ago, and it's a good company, but the problem is they're very expensive on shipping. I don't care how light the item is. The minimum shipping is $7 or $6.95, and you don't mind if you get something this size. And they go up from there, you know, depends on the price. So the more you pay for something, they don't go by the weight. The more you pay for something, the more the shipping costs. But these are used motors that they cut out of equipment. You can see where they've sawed them off. But this is 150 RPM. So it's too fast to connect directly to the stick like this. Now, I was going to mount it like this and probably put a pulley here and a pulley here with a belt, but with this head turning so hard here, it wouldn't do it. So what I need is a motor that's geared down, and I don't even know how fast it would be, but 150 RPM is way too fast. I'm going to say probably 20 RPM. I'm only guessing at that because I actually have to try it in here. And if this is geared down, if I had gears and I had a machine shop, you could add a couple of gears to this, mount it on a plate, and have another shaft coming out and coupled to this directly to a hose, like a heavy-duty hose like we got here, as a coupler. That would give me definitely enough torque. And being that I'm using a hose, it might still have a little comical effect with the shaking, which is what I want. This is the solenoid. Here is a close-up of it, which was sent to me by John in the UK. The first one I put in here from the American Science place burnt out because I kept doing the Dorkel skit and talking like continuously for 7 minutes, and it overheated and melted everything inside. So we're leaving this in place. This is the iMotor wire, so naturally you can't turn this too far, otherwise you stand to rip out the wire. So you can go around the other way. There's plenty of slack there, but I can redo that so it has even more slack. Not a problem. Now, I want to make mention, I have a couple of real good buddies. Actually, I have everybody that's really been very helpful. Dan of Cool Blue Lights, who replaced the button for me on the original remote. And I'm a junk collector for sending Dan the button. I appreciate that. Even though the other button failed, it's not their fault. It's just the way it is, you know. The fellow that sent me the camcorder, the Handycam, and the DVD recorder, a standalone DVD recorder, if you watched that video that I made a while back, he called me today, and he's going to send me double pole, double throw, center off, spring-loaded switch. In other words, it stays off until you pull it one way or the other. You only need one switch to do the head, my original design, and that's all you need. He's going to send me a couple of relays in case I need to go with the relay route. He's going to send me 10 foot of special wire, 18 gauge, 12 conductor. Don't need 12, but we can parallel some of the cords. He's going to send me 10 feet of that. He's going to send me a fiberglass box to put these things in for the remote control, which is going to be about 5 inches by 5 inches, so it'll be a box a little bigger than this and about 4 inches thick. That'll be perfect. There's only going to be, my design is, one button for the mouth control, solenoid, and he's going to send me that, and that's a 10 amp rated button, so he's sending me that. He's sending me the toggle switch, he's sending me 2 relays, sending me the wire, sending me the box, and not sure what else offhand. I'm trying to think of what he's going to send me. As far as the I motor is concerned, the I motor is continuous. In other words, the I, if you put 6 volts in here, there's a little, the way I built the I motor mechanism, which is inside Dorkel's head, there's a little crank in there that I made up. And the motor goes around and around and around and around, and each time it does, it turns the thing back and forth like this. So his eyes are going like this. And because of that, there's no polarity needed. I originally had it so you can turn the eyes one way or the other, but it really didn't need to be done that way because the eyes just move like this. So even if you left the button down, they'll just go like this. So all you do is you just hit it. So I'm going to use just one button on the new remote that I'm going to build to run the eyes. I'm going to use a double pole, double throw switch, which is going to be reversing polarity. In other words, you switch it one way, it puts the negative on the positive on the negative, because this is the reversible motor. You know, most DC motors are. So this is what we've been using all the time. Even though it's marked positive here, you can reverse it and it'll work just fine. It's a brush motor, so it's reversible. So that toggle switch will take care of the head. And the mouth trigger, he's sending me a 10 amp push button, which will handle the mouth solenoid, which only draws less than 6. As I recall, I think it draws around 5 amps activated. So I put a 6 amp fuse in there, so that's going to definitely take care of it. The head motor, normal load is about 6.5 to 7 amps, as I recall. So I put an 8 amp fuse in there, but you can see how much play there is in this bearing here. There's a little gear in here. So this goes too fast anyway, so we're going to have to order another motor if I can get one. And I'll mount it down here, and that'll operate this. Now, if you look up here, I put this in when I first built Dorkel, and I'm supposed to be able to reach down here and pull this, and it raises his arm, but ooh, that's hard. See? I had thought of motorizing that, but boy, that would take one hell of a motor. Probably take a half horsepower. There's no gears in it. It's just going through eye bolts in the shoulder, eye bolts in the elbow, and it's a very crude, non-workable system. So that's why I was never able to get his arms moved. And it was only done on the right arm. I did not do anything on the left arm at all. So I'm back to the drawing board as far as motor is concerned. I'm going to have to do some checking online and get a motor that'll run the head direct, geared down so to be high torque and hopefully doesn't draw any more current than this motor draws. You can only draw so much off these batteries. You can't draw 20 or 30 amps. It's not going to last long. Momentarily, it probably would handle it. So if I can get a gear-driven motor that doesn't take any more than 8, max 10 amps, fine. If not, then I've got a problem. Houston, we've got a problem. Thanks for watching.
Hello, I'm Dr. Flatner. I have my electric thermometer here. I'm going to be monitoring Uncle Dorkel's rectum. So, I'm going to be listening to his rectum. And that's what we're going to do right now.